Okay, so this will be a short version of the Git and GitHub tutorial to give you a little bit of a sense for how to use these tools. I'll just start by motivating them briefly. Git is a tool for what's called version control. What it provides to you is a little command line application that lets you track files in your computer. And by track, I mean store different versions of these files in the computer so that you can go and see what state a particular file was in previously and keep track of the changes that are happening in a very fine-grained way. And we'll see what that means in just a minute. GitHub is a different thing. It's a website, and that website provides you the ability to upload files and folders that are tracked with Git and track their development with others also. So different people might be making changes at different times, and they will each use Git to track those changes on their computer. And in GitHub, they will get together and they will track the changes that each are doing, and they'll be able to exchange changes. So as we're working on a project together, I will be able to pull down, it's called pulling, pull down the changes that you're making to the files that we're working on together. And I'll be able to push my changes as I go and do them. And that's very nice because pretty quickly you can update files on your machine to be exactly like the files that are on my machine and sync them up. And in contrast to things like Google Drive or Dropbox and so on, we have very fine-grained control over that process. We can also see what changes have happened and where. And Git and GitHub together provide all of that for us in a fairly seamless way. Okay, so with that, let me jump into the hub. I'll share my screen. And I'll show you how you can do this kind of work in the hub that we're using. So if you log into hub.neurohacademy.org, you can follow along. A lot of the work that we'll do today will take place in terminal window. So if I click on plus here, that opens this kind of launcher window. If I click on the terminal, it'll open one of these terminal windows for me. And so a lot of the work that we'll do will be in this terminal. This terminal, we also call this a shell. This is the Unix shell. And it allows us to interact with the operating system and with the file system, get information about it, and also start to make changes to it. So the basic unit of operation of Git is what we call a repository. Repository is a folder within our file system. And everything that's inside of the repository, inside of this folder, is tracked together. So the first step that we might make is to make a directory. Let's call it my paper, cd, change my directory into my paper. And because I just created it, if I type ls, there are no files in there at all. And so when I start a project, I might use Git in order to I'll initialize the repository in here in order to tell Git that this is a part of the file system that I would like to keep track of. So I type git init. And Git tells me you've initialized an empty Git repository in this location. And it points to a hidden directory. In Unix, directories that start with a dot are hidden directories. And indeed, if I type ls-a, which is the flag that tells me, show me also hidden directories, you'll see that there's a directory here called .git. This is the directory in which Git will keep track of things. It'll store different versions of the file system in there. And we actually don't need to touch that. That's sort of Git's private folder and keeps all kinds of files and folders of information that Git needs. But we don't need. We will manipulate that via the command line. So let's say, as a simple example, that we are going to track the writing of a paper. You can track different kinds of things with Git. Typically, these kinds of version control systems started off as tools for engineers that were tracking the writing of code. But you can track other things like text. And anything that is text, you can track with Git. For example, the writing of a paper. So let's say that I'm creating a file that will be my paper. In this case, I will use a text editor, a simple text editor called Nano that is installed in the hub to edit my text. Let's call it paper.md. And when I type nanopaper.md, it will pop open this window that's inside the text editor. So I have an empty text file in here. Maybe I type the title. Okay, so I write some text in here. This will be my paper. And I'll close this out. One thing that's nice about Nano as a text editor is that at the bottom here, you can see it has all the commands written out. The little caret represents the control key. And so Control O lets me save this. It asks me, is this the file you want to write? And when I hit enter, it saves that. And then Control X exits back into the shell. So now I'll type another git command, git status. Git status lets me see what the state of affairs is currently in the file system. And it tells me that I'm on a branch called master. Git has a notion of branches, so you can track the changes in multiple parallel branches, multiple different versions of your file system. But we won't see much of that today, and we can follow up on that on a different occasion. It says there are no commits yet. Commits are the name that Git has for checkpoints at which you've stored a state of the file system. And then it tells us there's an untracked file in here called paper.md. And you can, and it gives us a hint here, you can use git add file to include in what will be committed, what will be stored in the next commit, the next checkpoint of the file system. And so this is an important principle of Git, is that for you to store a version of the file system, you need to explicitly tell Git what it is that you're storing. And you do that by using the git add command. Git add paper.md tells Git, I would like to track this file, add that to my repository, add that to the things that you're tracking within this folder. And then if I type git status, you'll see that the status has changed. Instead of untracked files, we now have changes to be committed. And it says, oh, there's this new file that's part of the changes to be committed. And once we do that, we are ready to make a commit. Making a commit means storing a particular state of the file system. We're going to store, for example, the fact that we added this file and that this file has the content that we've written into it. So git commit. Git commit now opens, I should actually, let me save this and close. One more tiny thing that you'll need to do on your end for this to work is to introduce yourself to Git. For this, you need to do a little configuration step. You need to write git config -- global user.name and git config -- global user.email. So if you're following along on your side, the first thing you need to do with Git is you need to introduce yourself to Git by configuring this global configuration that stores your username and stores your email address. Git is pretty insistent on that. If you were to try to commit here, if you were following along and you tried to commit here a change, it would tell you, I don't know what you're doing. Please configure this thing before I can talk to you. And that, you'll see how that plays into the way that Git stores versions of the file system. One more thing that you want to configure here at this point is global core.editor and store that as nano. So I'm going to use nano here for the purpose of as the text editor that Git uses, and I recommend that you also use nano as a text editor. I should say this is a step that you need to do just once on any computer, on any new computer that you're working on. The fact that I told it that it is global here by saying -- global means that this will be stored as a global configuration for my user on all of the repositories that I am using on this machine. So this is something that will translate from repository to repository. So for example, as you're working on projects next week, you'll be already set up in terms of the configuration. You won't need to do this additional step. Okay, so having done that, now I can type git commit. And what that will do is it'll open this nano window, this text editor again. And in this text editor, it's asking me to enter the commit message for the changes that I've made. So here, what I'm going to do is I'm going to describe what I'm storing right now. Initial commit with beginning of a paper. So I'm writing a little message, and I can write a multi-line message here. This paper will discuss brain connections in source. Now, these commit messages are important because these are commit messages that you'll be able to see as you're browsing through your repository. And so it's pretty important to provide informative commit messages. Think of this as an email that you're sending yourself 6 months from now when you come back to see what you did, and you'd like to know what changes you made and why you made them. So I'm writing that out and saving that. And Git tells me you've made an initial commit, or this is the commit that happened, and this is the first line in the commit. The first line in the commit is usually, in the commit message, is usually kind of like the top line message about this. And it told me there was one file that was changed. It had 4 insertions because the file had 4 lines to it. So now if I type git status, it will tell me you're on the master branch, there's nothing to commit, and the working tree is clean. That means everything is nice right now. And this is the state at which you're ready to maybe, this is the state you'd like to be at when, for example, at the end of your workday. But for now, let's keep working. So let's say that I'm continuing to edit my paper. I'm going in here, and let's say that I'm going to add an author line here. Okay, so I've added a change. I'm typing Control-O and Enter and Control-X to exit. Now when I type git status, you'll see that it keeps track of things. It says, oh, there's some changes that are not yet staged for a commit. So it says, this is what Git does. It says, this is a file that I'm tracking, paper.md, because you told me that you want me to track this file. You've git added this file over here. I typed git add this file. So I'm going to, from now on, I'm going to keep track of whatever changes happen in this file relative to the previous commit. How do I know what changes exactly occurred? I can type git diff, and that'll tell me exactly what the changes are. So it tells me in here that the message that Git gives me back includes the file in which the changes happened, and also exactly what lines changed. So you see in green the addition of these 2 lines. These were the 2 lines that I added, one line that contains content and another line of white space that I added between the last time I committed and now. If I go back into here and add more, so saving that and typing git diff, what you'll see is that Git now keeps track of all the differences. So it's added this to the diff. So it's saying these are all the changes that have happened since last time you made a commit. And so maybe now I'm happy and I'd like to make a commit again. So I'm typing git add paper.md. And this is important. Again, you have to be really explicit. You have to tell Git what you want to keep track of. So I use the git add command, both in order to initially tell Git, this is a file that I'd like you to keep track of, but also at every point during my development, I use git add in order to tell Git, these are changes that I want you to introduce into the next commit. Now, before I do that, I'll just show you git status. The git status right now is there are changes, but they are not staged for a commit. And if I type git add paper.md, then now Git status will be will change from changes not staged for commit. Instead, it will say, oh, there are some changes to be committed. So what I've done in effect is I've taken these changes that were tracked by Git and I've told it, look, add this into what's called the staging area. The staging area is where we put all the things that we would like to put in the next commit. Now I'm ready to make another commit, git commit, added author line and added some content. So these are, again, a description in this commit message. I'm describing what are the things that I changed in the repository that are included in this checkpoint. So Control O, enter, Control X, saves that. And so now if I type git status, it will again give me this message, nothing to commit, working tree clean. So that's the basic workflow in Git. You add a file, git add file name, adds the file. You make some changes to the file, git add file name, git commit, write a commit message. Make more changes to the file, git add file name, git commit, write a commit message, and so on and so forth. So that's most of what you'll be doing with Git. Pretty much looks like that. Git add, git commit, git add, git commit with editing in between. What does that give us? Well, the first thing that it gives us is the following. It gives us a log of the changes that have happened. So if I type git log, now I have a linear log of all the changes that have happened in reverse chronological order. This is the first thing that happened, and then this is the second thing that happened. And as I make more changes and more commits, I'll get more and more items in this log, and it will get longer and longer. And this is neat because each one of these commits is identified by this long string of letters and numbers, which means that I can go and visit different states of the repository. I can rewind the repository to previous states of affairs using this identifier. Let me demonstrate that here by, first of all, let me pause here for a second and see what questions people have so far. All right, good.
One thing that I guess is always a struggle for me with GitHub is like just getting to like a Jupyter Notebook and like working out of a Jupyter Notebook instead of just like my personal PC. So like, let's say I'm trying to like upload something to like my lab's GitHub. Like if I wanted to do that using like a Jupyter Notebook and then like commit it to like my lab's GitHub, like how do I launch a Jupyter Notebook like on my own computer to do that? And like how do I make sure that it's like uploading correctly?
Yeah, let's add a Jupyter Notebook in here and see how we work with Jupyter Notebooks as well. Jupyter is a little bit of a tricky situation, but it's one that's really a common use case and really important. So I'm going to pause here on that for a second. I'm going to launch a Jupyter Notebook, and that adds this Jupyter Notebook in here. I'm going to give it Dino analysis. This is going to be our analysis. So this is pretty typical, actually. I do a lot of this where I have some notebook and have some text, and they're related to each other somehow. We're going to do some analysis here. Import numpy as np, np.random.rand number 100 a equals a plus 2. Okay, so I generated some random numbers. I added 2 to them. Here I am, and I'd like to keep track of this. So Jupyter is a little bit of an odd one, and that's because this .ipynb file, in fact, is a text-based format. Everything here is stored as text in a file called dinoanalysis.ipynb. But the front end, the Jupyter Notebook front end, takes that text and interprets that into this kind of format. And so the best practice here in terms of version control is not necessarily to store all these results, because that will lead into potential clashes with other people's work, but instead to restart the kernel and clear all the outputs. So I'm restarting that. Now I'm storing just the code that was here. Since this is a random number, I'll get different random numbers every time, but let's say that you fixed the seed and you get the same numbers every time. Now you can go in here, you can type git status, and now it'll tell you two interesting things here. There are untracked files, it says. First, this is notebook. And then there's another directory called .ipynb checkpoints. So let's deal with both of these. First, let's deal with the dyno analysis. Git add dyno analysis.ipynb. So now when I type git status, it'll tell me, look, you got changes to be committed, and then there are untracked files. Now here's how Git operates a little bit. We can start by making a commit first. I'll do a commit first, and this commit is add analysis notebook. Yes, save. Okay, so it saved that. And then if I type git status, it'll tell me, you'll notice the difference between this git status and this git status is the new file dyno analysis is no longer an issue. Instead, we just have this .ipynb checkpoints. And those are checkpoints that Jupyter keeps track of, and we don't want to keep track of those in our repository. We don't want to add these checkpoints into our repository. So we're going to create a file that we call git ignore. And in that, we're going to type ipynb checkpoints and save that file. And so now when we type git status, you'll see something funny happen. .ipynb checkpoints is gone. That's because we told Git to ignore it. But now we have .gitignore that was added. .gitignore is a file that Git recognizes. It's a file that you can put in various patterns of things that you'd like to ignore. Typical things to put in there are things like these checkpoints that get generated by various applications that you don't want to keep track of, or maybe you have a data folder in there that you don't want to keep track of. So you add that in there. I'll show you how to do that. Let's say you have a data folder, data / will basically ignore everything that's inside of a data folder. Okay, so the next thing to do then is to add the git ignore into the repository, and then git commit added .gitignore file. Okay, so now let's look at the log. The log has gotten quite a bit longer here. We have one commit related to the addition of the analysis notebook, and one related to the addition of the gitignore file. Now, more specifically about the ipynb, part of what's tricky about this is that when you're editing .ipynb notebooks, especially if you're collaborating with other people, you might come into conflict with the changes that they make. You'll make some changes, they'll make some changes, and those changes will be incongruent. And so you have to be a little bit careful there. You have to keep track. For example, you might, something that I quite often do is that I make copies of the notebooks. It's a little bit counter the Git version control, but I make something like duplicate this file and then rename that to 2021-07, what is today? 22 dyno analysis. So I have sort of a version of this that I've tracked the old way, not using version control. And in here I can do various things, and nobody else will have this. So it never will come into conflict with what other people are doing. And I can share that, and other people can see what I did, but then they'll take that and use that in their own notebooks. So that's one thing to do is 2021-07, 22 dyno analysis status, git commit as another notebook with today's. So that's one way to deal with the Jupyter notebooks, is to make them sort of unique to each one person. The tricky bit is if you do end up with conflicts, Git will try to resolve these conflicts for you. And that might make the Jupyter notebooks unreadable by Jupyter. I will say there are other solutions to this problem. I'll post some other solutions later on that we won't go into here, but there are technical solutions also to keep track of these things. In particular, there's something called Jupytext that helps you deal with that quite elegantly. So I'll post about that later on. Okay, that said, now our log is several items long. Let's see how we can travel back in time to a previous state of the repository. So just to remind you, we have this file and this file and that file. But let's say that we made some changes in here when we'd like to see what the state of that file was when we were in this commit. So we're way up here, but we'd like to go back in time to here. So one thing that we can do is we can do a git checkout and give it explicitly the commit identifier, this long string of letters and numbers that belongs to this other commit. The way I think about it is git checkout is a command to Git to go into its own library and check out a book or check out a particular state of the repository, in this case, the state that existed back here. When I type this git checkout and this long string, it will type out a bit of a warning here. It'll say you were in some kind of detached head state, and you can look around, you can make changes, commit them. You can do all kinds of things that you could otherwise do. And this looks pretty long and ominous, but it's actually not something that we need to worry about too much. What we do want to notice is that now if I type ls, you'll see that the notebook files, for example, are gone. And that's because back when I was here in this commit, those files didn't yet exist. And in fact, the state of this file is now as it was. If I go to nanopaper.md, it's exactly where it was in that commit. So when I typed, and let me close this, when I typed git checkout this, what Git did was switch over my file system. The contents of my file system were switched over to contain exactly what they had back when they were in this commit. And I can go back to where I was before by typing git checkout master. And that will now put me back where I was. So remember, when we type git status, it tells us you are on branch master. And so when I typed git checkout master, what it did is it went to the library and says, where's the master branch of this repository? Let me check that out and return the file system back to the state that it was on this master branch. And so now we're back where we were. So we can travel back and forth in time in the repository using the checkout command. Okay, so I'll sort of recap again. We create a repository typing git init. We type git add to add files. We type git commit to make commits. And then we'll, work, git add, git commit, and so on. If we need to go and visit some other state of the repository, we'll use git checkout. And you also saw if we want to ignore something, put it in .git. Okay. So now let's add some complication to this. What I'm going to do next is I'm going to show you how, so this is something you can do on your own, and you can do it on your own machine, separate from other people's work. But now what we're going to do is we're going to go and try to share this work with other people. So in order to do that, I'm going to go to GitHub. Let me open GitHub here, GitHub. What did I call this? I called it my paper. So here I am on GitHub. And depending on how you have things set up, you might see some messages here. And what I'm going to do is I'm going to click on this top right on this plus sign and choose to create a new repository. So we have the repository on our own machine. That's this folder with all the files in it and the history that's tracked. What I'm going to do is I'm going to create a copy of that on GitHub. And I'm going to call it the same thing, my paper. It says my paper is an available name. You can use that. I'm going to make this a public repository. And I'm going to initialize it without anything. It gives us the option to initialize the repository with for example, with a gitignore file already in there, or with a README file already in there. And that's one mode in which you might use GitHub, is to create the repository in the first place. But for now, we're going to create it empty. So when I click on create repository, it creates this website here. This website that you can actually go and visit, github.com. This is my username, Ariel Rokem, /mypaper is the repository for this set of files. And when I start it empty like this, it gives me some helpful advice. You can start by creating a new file from these buttons up here, or upload an existing file from your computer, or you can follow these instructions to, for example, push an existing repository from the command line. Okay, so the first command here, git remote add origin. Let me go back to here. So I'm copying over the command, the first command, git remote add origin. And then it gives me this address. And this address is an address that Git recognizes as the address of this website, this repository on GitHub. And so this is a pretty long command. Git remote. Remote is this is the subcommand that deals with repositories that are stored elsewhere, for example, on GitHub. And git remote add means I'm going to add a new place that you're aware of. Origin is going to be the name of that place. I'm going to call that remote origin. That's the name I'm giving to this remote that's associated with this address here, git@github.com, Rokem, mypaper.git. Okay. So that adds this remote to my set of remotes that I have. And in some situations, you might want to push your repository to more than one place. In this case, we only want to push it to this one place. Next, I'm going to do something that GitHub recommends, which is to take the branch that I called master and modify its name to be called main. And that's a move that GitHub has adopted, because the name master, that is the default name for the branch that gets, when Git first initializes a repository, it creates a branch that you can use, and it calls that branch master. But that name has all kinds of unfortunate connotations. And so what GitHub recommends is take that branch and change it to be called main from now on. So now when I type git status, you'll see that I'm on branch main, not on branch master anymore. And other than that, nothing has changed. Git log is just a better name for that thing. And then when I type git push -u origin main, this is the point at which GitHub will authenticate me and will take and move. So this is the authentication step. I'll talk about this in just a second, what exactly is going on here. But for now, let's just set that aside. There's some authentication taking place, and it does all kinds of things here. And it says, I've set up a branch to track your branch main in the remote origin. And now when we go here, what you'll see is that all of the files that were on my machine are now on GitHub, up on GitHub. And so now other people can look at my files. For example, they can look at my notebook with its code. They can look at my paper with its title, author, and content. And even my git ignore that I added is in here with whatever content was in it. And more than that, all of the history of this repository is in here. So if I type on this commits tab here, it'll show me all of the history. For example, I can go back to this previous state of the repository, and it'll show me what was added in this particular commit. You see in green the additions of the author line and some content. And this is also reflected in the commit message up here. So what GitHub does is it stores the Git repository, including its history and its files as they are currently at the end of the development. Okay, let me go back to this little line here. I'm debating whether we should do this together now, because it is a few steps here, but let me do that. I'll show you what you need to do in order to be able to do this authentication. What GitHub requires for authentication is what's called a key pair. A key pair is a way for GitHub to authenticate us without a password. So without typing a password, GitHub is able to authenticate us by comparing a public key that we will give to GitHub and a private key that we have stored on our machine. And so the way to do that is there are a few sort of sequence of commands that we need to do. The first, and this is true particularly if you're working on the hub. If you're working on another computer, like another operating system, then the set of commands will look slightly different. So, but let's go with the set of commands that you will need to type in the hub. And then if you need more guidance on doing this on a Mac laptop or a Windows laptop, I can show you where to find that information. So the first command is SSH keygen -t ed25519-c, and then my email address. There, like that. And I already went through this step, and so you can see that it has a passphrase associated with this particular key. What will happen here now is if you're doing this for the first time, it'll generate this file for the first time for you. So it's saying, I'm going to generate a public-private key of this kind, ed25519, which is what GitHub recommends. And then it says, should I save it in here inside of this folder called .ssh as this file name? And I say, yes, let's do that. And it says, oh, you already have that. And that's because I did this before. And I'll tell it to override it. And it asks me whether I want to protect this key with a passphrase. And so you can type a passphrase here if you'd like to for additional protection. And that's the passphrase that I needed to enter here in order to use this key. And I'm going to do that on my end. And then it asks me to enter that again. And then it gives me some things. It created the file. I need to do 2 more steps here in order to make this key usable. I need to type eval quotes $SSH-agent -s quotes. And that starts an SSH agent. And then I need to type SSH add, and I need to point to this key file that I have. And I need to type the passphrase for it. And so this adds this identity on this machine. I need to do one more step in order to make GitHub aware of this. I need to go to github.com/settings/keys and tell GitHub about this key by adding a new SSH key here. Let's call it Jupyter Hub NeuroHackademy Jupyter Hub, like that. And what I'll give it here is the public part of my key. So I go back to the terminal, I type less.tilde/.ssh, and it'll tell me you have the key, the private key part, and you have this public key part. And what I'm going to do is I'm going to give GitHub this public part. So that's one line. I copy this line over. I type Q to exit this less buffer. I add the SSH key in here. And now I have to confirm my password here because this is private information. And so now this key is recognized. And now I'm able to do what I did before, which is push to this repository. OK. So once I've done that, then authentication is set up and all is good in the world. Let me just show you how you might collaborate with other people on this repository now. So far, what I've done is I've tracked files on my machine, and I've made changes, and I've pushed these changes into GitHub. But typically, the way that Git and GitHub are used is actually in collaboration with others, and they enable this kind of collaboration by making sure that you have the same files that I have. So what I'm going to do here is I'm going to add a collaborator. I go to Settings, I manage access, and then I invite a collaborator. Let me see if I can find one of you. Is that you, Shelby? I guess so, yeah. All right, so I'm adding Shelby to this repository, and I'm going to put you on the spot here a little bit, Shelby. So when I did that, you should have gotten an email that said, hey, Ariel invited you to collaborate with him on this project. Do you accept that? And you need to go in there, and there's a big green button, and you need to click on that green button in order to confirm that you're my collaborator on this work. Otherwise, things won't work. OK, so you got it. OK, great. So then, in order to get my code, anyone can get my code, actually. You can go in here. You can click on, if you go to this address, this is a publicly available repository. You can see this. you can click on this download zip and it will download a zip of this paper with all the content in it. So there's a way to get the files really, really quickly through here. But what I'm going to show you now is how you would then copy this in a way that you can then push changes into this. So what I'll do here is I'll sort of walk you through what I hope Shelby can follow along and do on her machine. Is I'm going to go into a temporary folder, on my, and I'm going to do the following. I'm going to do Git Clone, and I'm going to give it this address. Git Clone means there's a repository in this location. I would like you to make a clone, a copy of this onto my machine. And if you do that, then it will say I'm cloning into a folder called my paper. And now in here I have, well, I have Git paper from last time that I did this, this tutorial the other day. And then I have this my paper folder, which is what we're doing today. So let's go into my paper. CD my paper. And in here, I have the same files that I had in my repository. Notice that I moved to another part of my computer in order to demonstrate that I can easily make a copy of these. So I'm in a different place, and I have the same files in that different place because I asked Git to clone those different files into this other place. So I kind of simulated what could happen on a collaborator's machine. And so now in this location, I can go as a collaborator. For example, Shelby could on her machine do something like nanopaper.md, and then, for example, add her as an author. Are you following along, Shelby? I'm hoping so.
I had to restart it. My internet's bad today, so I just restarted the Jupyter Notebook, and I'm in the temp. I just opened up the temp, so I'll have to just go back and look at your code in a second, but I'll be there soon.
Okay, I'll keep going here, and then we'll try to do this. Sorry, I would like to demonstrate how this collaboration thing works. So so now I'm typing git status, and it says, oh, you made some change to the paper. And as a collaborator on this work, if I followed all the steps, I did the SSH key, I cloned the repository, and I made a change, I can make a git commit here, git add the file, git add paper, and then git commit to say adds another author to the paper, and then the final step here is git push origin main. That's the last step here. Git push origin main will take this change and will then do the authentication step for me and push it into GitHub, so that now if I refresh this page, you'll see that the last commit here is this actually this, and the content is also changed so that Shelby is also included as an author on the paper. So that updated, when I did git push, it updated the remote repository to the state of the local repository on this machine. And if I go back to my original repository, my paper, which was in this other folder, my paper, and I type git log, you'll see that this has not made it here. I'm still in this previous state here. And if I open in here nanopaper.md, you'll see that it still doesn't have this addition. So this update doesn't happen automatically. Instead, what I need to do in this other place is git pull origin main to get down the changes that have happened. And when I pull these changes, then the repository updates. Git log will show me that there's now this additional commit. And so this kind of completes the loop here. So I showed you before how you would work linearly by yourself. Now I showed you a little bit about how you would work with others. So the workflow gets a little bit more complicated. You do git add, git commit. You might need to do git remote add to add a remote repository origin, and then with the relevant address, git push origin main will push your changes to this remote, And then if somebody else does git pull origin main, that will pull those changes. Now, this other person that did the pull first needs to do git clone, this address, so that that machine goes onto your machine. So that's, in a nutshell, that's the simplest collaborative workflow that you can use using Git. You continue to do git commit, git add, git commit, git add, git commit on your local machine. Then you push, and then somebody else pulls, makes their changes, pushes and pulls. And unless you're changing the same line in the same file, Git will actually cleanly merge. Even if you're working at the same time on different files, it will cleanly merge the histories of your different repositories nicely. If there is a change in the same file, in these two different places, in the same line, in the same file, then you will run into what's called a conflict. And I'm not going to show in detail now because we're already very close to where we need to end this in terms of time. I'll just mention that that's fine. What Git is telling you when it's telling you that there's a conflict is that you've introduced changes that it doesn't know how to merge. And you need to go and edit the file and resolve those changes by yourself, making another commit to tell it that that's been resolved and pushing that. And so if you and your collaborator have some conflicting changes in your two versions, both of those versions will be stored in the history. And ultimately, you'll be able to edit the file to make sure that you have one true version, and you keep going from there on. So that's nice if you've made multiple changes and you want to go and visit and see the changes that your collaborator has done. You can see them in the history, but ultimately the state of the file system will be such that it's got the final true state. You can go and edit conflicted files, and Git will let you store both versions and also the final state of this. Okay, so that was a whirlwind through Git and GitHub. A final word about Git and GitHub is that it takes a little time to wrap your head around Git and GitHub if you're just getting started with Git and GitHub. For me, it took a few months until I felt really comfortable using this tool, and now it's in really indispensable part of my toolbox, especially in collaborating with others. And I should say, as you work with it, you'll expand the kinds of workflows that you can use into more elaborate collaborative workflows. And I think one maybe nice thing about the structure of NeuroHackademy is that hopefully next week we'll get to work a lot with Git and GitHub, and you'll get to work with folks that have more experience using Git and GitHub, hopefully myself and others here. And we'll be able to sort of walk you through these things. So it's one of these things that takes a little bit of time, and it takes a lot of practice to get used to. Just seeing it once is probably not enough. Instead, doing it yourself a few times with maybe somebody else looking over your shoulder or looking at your shared screen, as the case may be, is a good way to learn how to use Git and GitHub and eventually get used to it and appreciate the kind of flexibility and durability and speed and so on that it adds to your collaborative workflows. Okay, so I'll pause here and see what questions people have about things that I've shown so far. Okay. Yes.
I had a small issue earlier when you tried to copy over the public key, and you had the command less and then I think the tilde slash .ssh, and mine just says it's a directory.
Oh yeah, the command was less .ssh id like that with the full file name.
Got it.
And that should show you something like this on your end. Maybe you can follow on from there. I should mention also that all the notes for this this entire thing, and I'll put that in Slack here. All the notes for this are in a website. Oh, I need to move you folks out of the way. So all the things that I mentioned today, including those of the elaborate instructions about SSH keys, are in this Git course, and definitely Slack me if you see that you run into issues there. Okay, let's take quickly another couple of questions. Kai.
Hi, Ariel. I'm aware of time, but I just sort of want to ask and hope that you can get to what is a pull request in GitHub. But can you put that in really short and quick?
Top
or,
level, it's a situation where you're collaborating with people that you don't quite know, and instead of them pushing directly into your repository, they push into a place where they can where you can discuss things with them. And then if you look at their code and you like what the changes they're proposing, you can click on a button and you'll get pulled into your repository. So that's a pull request. And we can look at pull requests. I think it'd be better to look at that in the real context of a project and do that together maybe next week.
Okay, cool.
Okay. Hee-jung?
Hey, Ariel. Thank you so much for the intro. And I kind of stuck around to get your opinion on a problem that I have. So we have a data repository or a data folder and an analysis folder, and for multiple reasons, like keeping them separately, it's easier to share data and keeping your analysis separate. So one of my questions is, how do I manage that in Git? Because would I use the remote to say that there are two different instances of a data folder and an analysis folder, or do I need to create two different Git repositories? I'd like to know your thoughts about this.
It depends a lot on the nature of the data. If the data is small enough, as tables, for example, not brain images, then you can manage it with Git. But if it's very large data, then you might need a different tool. One tool is called Dataland. I think Satra mentioned Dataland. That manages very large data well. For me, often in projects where the data are small enough to be managed, I prefer to have everything together, have the analysis and the data side by side, or at least have a clean way of getting the data close to where the analysis is, maybe a little script that downloads the data into a folder that is always in the same place. And that's for purposes of reproducibility, so that I can click one button and get the analysis to run. But it depends a lot on a lot of details. It's very elegant to have everything in one repository so that somebody can clone that, run your analysis, get the data into a data folder, for example, download it from one location into the data folder, and then everything runs and you get all the figures in the end. That's really the ideal in terms of reproducibility, is being able to do that.
Great, yeah. Thanks for the suggestion. And I'm on board with Dataland. I'm actually using it for my neuroimaging data as well. Like you said, the data is neuroimaging data. And if the folders if the data and the analysis are in two separate locations, and the Git repository is built within the analysis folder, how would I combine them?
That would be tricky to describe within
Okay,
limited time.
maybe
let's take that later.
Yeah.
The time is already late, and I'd like to take a 5 minutes break before the next lecture, which will start at 12:40. So maybe let's come back to that later on. And,
sounds great. Thank you.
Okay, so I'll see you all in 5 minutes in Eva Dyer's talk.